Let's go ahead. Okay, so today we are going to start a new chapter, okay, called Biomolecules. So, this is one of the biochemistry lesson I can say. Okay, you will enjoy this lesson. And the learning objectives for this lesson are carbohydrates. We will discuss about proteins and amino acids, enzymes, vitamins, nucleic acids, and hormones. So these are the different types of biomolecules we are going to discuss in this session. Okay, this lesson. So let us start with the carbohydrates. Okay, let us start with the carbohydrates. What are carbohydrates? Carbohydrates are called as the hydrates of carbon. Initially, the carbohydrates were called as the hydrates of carbon. Okay, hydrates means water, right? Hydrates of carbon is called as carbohydrate. Got it? And the general formula for the carbohydrates or the hydrates of carbon was said to be CX and H2OY. CX and H2OY. So let me give you an example. Glucose is an example. C6H12O6, where X is 6 and Y is also 6. Okay, C6H2O6 times is the formula for glucose, and this is the example. But there are some exceptional cases. Okay, the very first exception is the acetic acid. So if you look into the acetic acid, we have 2 carbons, 4 hydrogens and 2 oxygen, right? So which falls under C2H2O2 formula. Okay, so this is the formula for acetic acid. But it follows this hydrates of carbon formula and all, but it is not a carbohydrate. It is not a carbohydrate. It is an acid. It is not the carbohydrate. Okay. And the another example is rhamnose. Rhamnose formula C6H12O5. It doesn't fit into this formula, but it is a carbohydrate. So we can say that few compounds are falling into the formula, but they are not the carbohydrates. But some compounds, they doesn't follow the formula, but they're acting as a carbohydrate. Got it? So, by seeing these types of compounds, scientists have come up with a new definition for carbohydrates in the days, okay, in the upcoming days. So they said that carbohydrates are not called as hydrates of carbon. They are called as the optically active polyhydroxyaldehydes or ketones. The correct definition for carbohydrates followed till today is they are the optically active polyhydroxyaldehydes or ketones. So what is meant by optically active? The compounds which have chiral centers. They are called as optically active compounds. And polyhydroxy. Polyhydroxy means more number of OH containing compounds. Okay. So more number of OH should be present in the aldehyde or ketone. They are called as carbohydrates. So I will give you the example with the structure. So these two are the structures of carbohydrates. The first structure is the structure of glucose and the second one is the structure of fructose. In the first molecule, we have CHO group, which is called as aldehyde group, and the second is called as ketone, RCOR, right? So the optically active polyhydroxy aldehydes or ketones are called as carbohydrates. Got it? This was the latest definition and we have to follow this definition only. Is it clear? Now let us do the classification. Classification of carbohydrates. So we can classify the carbohydrates based on different behaviors. The first one is the classification on the basis of their behavior on hydrolysis. Second is on the basis of reducing nature, based on hydrolysis, based on reducing nature. So based on the hydrolysis behavior, it is classified into monosaccharide, oligosaccharide, and polysaccharides. And based on the reducing nature, it is classified into two. One is called as reducing sugar and the other one is called as non-reducing sugar. Okay. These are the two different types of classification of carbohydrate. So let us do one by one. First, let me take the first classification, which is based on the behavior of hydrolysis. Okay. So in that we have three types. One is monosaccharide. So what is meant by a monosaccharide? So if you hydrolyze a monosaccharide, okay, it will not undergo hydrolysis. If you try to treat this monosaccharide with water, it will not undergo that reaction. Okay, the compound which cannot be hydrolyzed further to give the polyhydroxyaldehyde or ketone is called as monosaccharide. Some of the examples are glucose, fructose, ribose. So these three sugars, these three saccharides, monosaccharides are the examples under this category. Glucose cannot be further hydrolyzed. Fructose also cannot be hydrolyzed. In the same way, ribose also. Got it? Now coming to the second classification, oligo. Oligosaccharides are the compounds which on hydrolysis, they undergo hydrolysis and they produce 2 to 10 monosaccharide unit. The one which produces 2 to 10 monosaccharide units on hydrolysis are called as oligosaccharides. Examples are sucrose, second one is maltose, and some other examples are also there. Okay, so in case of sucrose, if you hydrolyze the sucrose, you will get glucose and fructose. So they are yielding 2 monosaccharide units. So that's why sucrose is an example for oligosaccharide. Got it? Coming to polysaccharide will undergo hydrolysis and they will yield a large number of monosaccharide units on hydrolysis. More than 10. Okay, more than 10 monosaccharide units can be produced on hydrolysis. Examples are starch, cellulose, and glycogen. Okay. So the one which doesn't undergo hydrolysis is mono. The one which produce 2 to 10 monosaccharide unit on hydrolysis is oligo. More than 10 is called as poly. Is it clear to all of you? Can you able to understand the first classification, which is on the basis of behavior on hydrolysis? Is it clear? Shall we go for the second classification, students? Give thumbs up, say yes or no in the chat box. Okay. Thank you so much, Chandan Mandal and Bishan. The second is the classification on the basis of reducing nature. So there were two types, right? Reducing sugar and the non-reducing sugar. So what is meant by reducing? Reduce, the one which reduces the Fehling solution and the tolerance reagent. We have studied about this Fehling's and tolerance reagent in the aldehydes, the previous lesson, right? Previous to previous lesson. The aldehydes lesson, I have discussed about this. So the compounds or the sugars which reduce these two reagents are called as reducing sugar, and which do not reduce these two are called as non-reducing sugar. Okay. So let me take a Fehling solution. You all know that the color of the Fehling solution is blue, right? Because we use copper 2 plus ion in that Fehling solution. The copper 2 plus is the copper 2 plus color is blue. So the Fehling solution color will be blue. And if you add a sugar to this Fehling solution, and if you don't observe any change in the color even after adding, then you can come to the conclusion that the sugar is a non-reducing sugar. Okay. Examples are sucrose. Example, the only non-reducing disaccharide is a sucrose. Okay. But while adding the sugar molecule to the Fehling solution, if you observe any color change, for example, if I observe red color, if the color is changes to red, then the sugar that we have added is a reducing sugar. Okay. So who all will fall under this category? All monosaccharides will fall under this category. So all monosaccharides. Who are monosaccharides? Glucose, fructose, ribose. So all these will fall under reducing sugar category. And the sucrose is a non-reducing sugar. Okay. Now let us study about glucose and fructose. So let me take the first monosaccharide, glucose. The formula, molecular formula for glucose is C6H12O6. Okay. Where do we get glucose? The major source of glucose is nature. Okay, from the nature itself, we can get glucose in a very high amount. Okay, an example in case of ripe grapes and in honey. So like this, you can get the glucose from the nature itself. Okay, whose formula is C6H12 and O6. Now let us study some preparation of glucose. I'm going to discuss about two preparation. The very first is we can get glucose from sucrose. Sucrose is a cane sugar, right? From sugar cane you can get the sucrose. So what is the formula for sucrose? Can anyone tell me the formula for sucrose? Can anyone tell me the formula for sucrose? Do you know the formula? Very good, Bishan. It is C12, yeah, H22, O11. Chandan, it is O11, not, yeah. Not H11, my dear, it is O11. C12, H22, O11 is the formula for sucrose. So if you hydrolyze the sucrose, if you treat the sucrose with water in presence of HCl and if you heat it, okay, you can use dilute HCl or dilute H2SO4 in alcoholic solution. You can do either one of these. You can add either one of these acid and by adding, we will get glucose and fructose. Both glucose, fructose will have the same formula. Okay, glucose will have aldehyde and fructose will have ketone. Only the functional group changes. Otherwise, the formula remains same for both. So this is the first method of preparation of glucose. Okay. Second method of preparation is from starch or cellulose. The formula for starch is, many of you may not be knowing the formula for starch. So I will give you C6H10O5N times. Okay, C6H10O5N times. If you treat this starch with water and heat it, you have to add dilute H2SO4 and you have to heat it to 393 Kelvin and the pressure is 2 to 3 atmospheric pressure. The pressure to be maintained is 2 to 3 atmospheric pressure. Okay. So at this reaction condition, the starch will be converted to glucose. N molecules of glucose will be formed. So if you want to prepare only the glucose molecule, you can go for the second preparation. If you want both glucose and fructose, you can go for the first preparation. But both the preparations are very, very important. Okay. Both the preparations are very, very important. Now let us study about the structural information about the glucose. Shall we go for the structural information? Do you guys have any doubt till this? Is everything clear so far for all of you? Karima Begum, Piali, Sivamani, Suman? Yes. I hope all of you are here, right? Okay. Let me go to the structure of glucose. So glucose has two different types of structure. One is open chain structure and the other one is cyclic chain structure. So let us first discuss about the open chain structure of glucose. We all know that the molecular formula for glucose is C6H12O6 and this is the structure. Okay. where you have CHO at carbon number 1 and the remaining 4 carbons next to it, and finally you have CH2OH. Okay. Now I'm going to discuss something which is very important. The reactions of glucose. Reactions of the glucose. So what happens if the glucose is treated with HI? What happens if the glucose is treated with HI? The glucose molecule, add HI and heat it. You will get N-hexane as the product. So why N-hexane is formed? N-hexane means 6 carbon containing hydrocarbon, right? We have 6 carbons in the structure of glucose or in the formula of glucose. So that's why we are getting a 6 carbon containing straight chain hydrocarbon. Okay. So how can we conclude this? What is the conclusion or what is the result we get from this reaction? It is very clear that all the 6 carbon atoms in the glucose molecules are linked in a straight chain. All the 6 carbon atoms in the glucose molecule are linked in a straight chain. Okay. If they are arranged in a branched chain manner or some other manner, then we will not get an N-hexane. We will end up with some other product, right? Since all the carbon atoms are arranged in a straight chain manner, a straight chain 6 carbon containing hydrocarbon is formed from this reaction. This is the conclusion. Conclusion from all the reactions are very important, students. So please take a note of it. Okay. So reactions may be there in your book, but the conclusion is very important. If you don't have, please write it. Okay. So let me go for the next reaction. Second is the reaction with hydroxylamine. What is the formula for hydroxylamine? I have discussed this in aldehydes lesson. Let me see who remembers the formula for hydroxylamine. Can anyone tell me the formula for hydroxylamine? Please try to give the formula for hydroxylamine in the chat box. At least one student. Formula for hydroxylamine. Okay, let's go ahead. So let me take glucose. Hydroxylamine is NH2OH. NH2OH. Very good vision. NH2OH is the formula for hydroxylamine. So if you treat this with hydroxylamine, you will end up with oxime. You will end up with oxime. I will tell you how to arrive at this product. So we have aldehyde group, right? C double bond O H. This is aldehyde. And it is connected with CHOH 4 times, etc. If you treat this with hydroxylamine, the oxygen from aldehyde and the 2 hydrogens from NH2OH will come out. Okay, so we have C double bond hydrogen and connect this nitrogen here, OH. C double bond NOH. So that is what is coming out as a product. And this is called as oxime. This is called as oxime. Okay, C double bond N containing compounds are called as oxime. Just remove the water molecule in this manner. Okay. Now the next reaction is heating with HCl. This reaction is very familiar to you, all of you, because we have studied this in aldehydes lesson. So if an aldehyde is treated with HCl, what will happen? So we have C double bond OH, right? C double bond OH. So we have H plus and Cn minus. We will break the bond. We will add hydrogen here and Cn here. So we will end up with the Cn and OH containing compound, which is called as cyanohydrin. Okay, the Cn and OH containing compounds are called as cyanohydrin. So break the bond, add H and Cn in this manner. So this reaction we have already studied. Now the conclusion from these two reactions are the presence of carbonyl group. Because in both the reactions, if you observe the reaction is happening only at the CHO position. It is happening only at the carbonyl group, right? So this is the present, this shows the presence of C double bond O carbonyl group in the glucose molecule. Okay. Now let's go for the next reaction. Reaction with mild oxidizing agent like bromine water. Now let us take the glucose and treat it with bromine water. Bromine water is an oxidizing agent. It is a mild oxidizing agent. So what it will do? It will oxidize the aldehyde. So aldehyde on oxidation will give carboxylic acid, right? So we will get gluconic acid by doing this oxidation. Bromine water, if the glucose is treated with bromine water, the aldehyde part of glucose will be converted to carboxylic acid. Okay. Now the conclusion from this reaction is carbonyl group is present as an aldehydic group. So we have several carbonyl groups, right? C double bond O, H is aldehyde. And if I have C double bond O, R and H is aldehyde. And if I have R and R, it is ketone. If I have C double bond O, OR, it is ester. If I have C double bond O, OH, it is carboxylic acid. If I have RC double bond O, X, it is called as acyl halide. So we have many compounds, many carbonyl compounds which has C double bond O. But this particular C double bond O carbonyl group is present as an aldehydic group is the conclusion from this reaction. Okay, only aldehydes can be converted to carboxylic acid on treatment with bromine water. Okay, if you have some other carbonyl group, it will not be converted to acid, it will be converted to some other compounds. Clear? So this is the conclusion we are getting. Now the next reaction is acetylation. Acetylation or acylation, both are same. Acetylation with acetic anhydride. So what is the formula for acetic anhydride? It is CH3, C double bond O, O, C double bond O, CH3, right? So if you treat this with acetic anhydride, you will get a product like this. So what is happening here? The H of the alcohol, the H of all the alcohol, OH part, is coming out with the CH3COO as acetic acid. And what we have at the end? We have a CHO group here and CHO, CHO, COCH3 is getting attached here. And finally, we have CH2O. CH2O is attached with COCH3. So the removal of acetic acid takes place and finally we are getting glucose pentaacetate. Glucose pentaacetate. All the OH is getting converted to the acetate ion. Okay. Now the reaction is happening at the OH containing place. So the conclusion is 5 OH groups should be attached to different carbon atom is the conclusion. Since 5 acetate groups are getting added to the compound, we can say the conclusion says that 5 OH groups are attached to the different carbon atoms in the glucose molecule. Okay. So these are the reactions. These are the reactions. We have one more reaction. Let me discuss that also. It is a reaction with nitric acid. So take the glucose and if the glucose is treated with bromine water, it is giving gluconic acid, right? If you still oxidize this gluconic acid with nitric acid, it will give saccharic acid. It will give saccharic acid. So this is the reaction which we have already studied in the previous slide. Now the gluconic acid on further oxidation with nitric acid leads to the formation of saccharic acid. So what is happening? The CH2OH group is also getting converted to COOH. What is CH2OH? Primary alcohol. CHOH means secondary alcohol. So only the primary alcohol group is getting converted to carboxylic acid. So the conclusion is the presence of primary alcoholic group in glucose. Okay, primary alcoholic group in glucose. So these are the reactions of glucose, and all the 6 reactions that I have discussed are very, very important. Okay. So we have only very less number of reactions in this biomolecules lesson, and the major part is the reactions of glucose. So all of you should know all the 6 reactions of glucose and the conclusions. Clear? Now let me show you the structure, open chain structure of glucose D and glucose L, D glucose and L glucose. So this is the open chain structure. Okay. So we have CHO at the top, CH2OH at the bottom, and in between we have CHOH 4 times. So if the last before carbon has OH in the right hand side, if the last before carbon has OH in the right hand side, then it is said to be the D glucose, D plus glucose. Okay. So D glucose. If OH is on the right hand side, it is D glucose. And the plus denotes that the compound rotates the plane polarized light in clockwise direction. You might have studied about optical activity concepts in class 11. Okay. So in that, the plus denotes the optical rotation. So optical rotation in clockwise direction. Plus means optical rotation in clockwise direction. Similarly, if we have the last before carbon attached with the OH in the left hand side, then it is called as L glucose. It is called as L minus glucose. So L means the OH group is on the left hand side, and the minus denotes the rotation of plane polarized light towards anti-clockwise direction. Okay. These are the 2 types of open chain structure of glucose. Clear? So any doubt from this? Shall we go for the cyclic structure of glucose? Students, can you understand? Shall I go for the cyclic structure of glucose? Okay. Now coming to the cyclic structure. So we can get the cyclic structure, and one is called as alpha D plus glucose and the other one is beta D plus glucose. Okay. So the Harvard structure of this alpha D glucose will be like this. So you have to arrange this in a cyclic, and these are the number of the carbon atoms, and to this carbon number 1 we have hydrogen and OH, right? So hydrogen at top, OH at bottom, and here to the second carbon, H and OH like this. Third one has OH at the top. So the components which are on the right hand side will come in the bottom. Okay, the the elements or compounds which are on the right hand side in the structure will come in the bottom in this structure, cyclic structure. And in the fourth carbon, we have H and OH like this, no? The OH will come in the bottom. But the fifth carbon has hydrogen in the left hand side, but it is coming in the bottom. Only for that, you have to make that change. And we have a sixth carbon attached to the fifth carbon. Okay. So this is called as alpha D plus glucopyranose. Why it is called as glucopyranose? I will tell you once I draw the structure of beta D glucose also. So listen the beta D glucose structure. So here what we have done, in the beta D glucopyranose, the OH will be at the top. Okay, OH will be at the top only for carbon number 1. So you have to make a change for carbon number 1. If OH is on the top of this ring, then it is beta. If the OH is on the bottom of carbon number 1, then it is alpha. Okay, but both of them are called as pyranose. Why it is called as pyranose? Pyranose, pyran, it is representing the pyran ring. Pyran means six-membered cyclic structure of pyran. Okay, it will be like this. So this is pyran. Okay, so it is similar to this, right? Pyran. Glucose cyclic structure is similar to this pyran structure. That's why it is called as glucopyranose. All right. So the cyclic structure as well as the open chain structure. Both the structures are very important for glucose. So in the fourth carbon also we have the uh, atoms. So we will have OH here at the bottom and H at the top. And the fifth carbon will have H at the bottom and CH2 OH at the top. Okay. So the only difference is the OH attached to carbon number 1. If it is attached in the bottom position, it is alpha. If it is present on the top position, it is beta. Okay, this is the only difference you have to keep in mind. Clear? Do you guys have any doubt from the cyclic structure and the open chain structure? Shall I go for the next monosaccharide? So far we have discussed about the glucose preparation, glucose reactions, and the glucose structures. Shall we enter into the fructose informations? Any doubt in glucose? You guys have any doubt in glucose? Okay. One is joined from the ID called Narendra Modi. Who is that? Can you mention the name of your JNB? Chandan, it is not minus, it is hyphen, my dear. Yeah, you may leave. You may leave. You may leave, my dear. The one who is watching from Azer, you can leave. Okay. I told you, no, L means the one which rotates the plane polarized light in anti-clockwise direction is called as L. Okay. One which rotates the plane polarized light in anti-clockwise direction is called as L isomer, and the minus denotes the optical rotation. Clear? JNB Nagun. Okay, okay. No, in the cyclic structure, there is no L representation, only alpha and beta. Only for D plus, we are doing this alpha and beta. Here only alpha, beta, no DL. Then, okay, all right. Shall we go for the next one? Chandan? Yeah. So the next is fructose, monosaccharide, which is called as fructose. As I have already told you, the molecular formula is same as that of glucose, which is C6H12O6. The major source of fructose is nature. Okay. For fructose also, it is nature. Mainly you can get from fruits and vegetables and also from honey. Okay. Now let us go for the structure of fructose. Fructose also has open chain structure and cyclic chain structure. So in the open chain structure from the formula, you can classify this on the basis of chemical reaction. Okay, fructose has 6 carbons in a straight chain manner in its structure. You see here. 6 carbon atoms are arranged in a straight chain manner for fructose. Okay. And it contains ketonic functional group at carbon number 2. In the structure of glucose, we had C double bond O at carbon number 1. But here we have the C double bond O in carbon number 2. Okay, and it belongs to D series because the last before carbon has OH on the right side, right? So it is D series and it is a levorotatory compound. So this will rotate the plane polarized light in anti-clockwise direction. So it is a levorotatory compound. Clear? So we will get minus. The sign optical rotation will be minus. So this is the open chain structure of fructose. Now let us study the cyclic chain structure of fructose. So this is the structure of fructose. The reaction, the attack will occur at the carbon number 2 because that contains the C double bond O. So if OH goes and attacks the carbonyl carbon, it will lead to two different types of structure. One is alpha and the other one is beta. Okay. Yeah. Okay. So if OH is present on the right hand side, it is called as alpha. And if it is present on the Chandan, you can go. Thank you so much. And if OH is on the left hand side, it is called as beta. Okay. And they form a 5-membered cyclic compound with 1 oxygen and 4 carbon atoms. They form 5-membered cyclic compound with 1 oxygen and 4 carbon atoms. I will show you the structure. So it is a 5-membered ring. Okay. With 4 carbon atom in the ring and 1 outside the ring. Okay, so these are the carbon atoms. 2 carbon atoms will be outside. And in this is alpha D structure and the other one is beta. So in the beta, you will have OH at the top. Okay, the second carbon attached to OH is at the top and here it is attached at the bottom. Bottom means alpha, top means beta for fructose. Okay, so this is all about the monosaccharides informations. So glucose and fructose. So we don't have any chemical reactions or preparations for fructose. This is all about the fructose. Only the structural informations are very important. The open chain structural information and the cyclic chain information. Okay. So next is disaccharide. So what is meant by disaccharide? So disaccharides are the compounds which on hydrolysis with acids or enzymes forms two monosaccharide. Those two can be same or they can be different. Okay, they are called as disaccharides. Examples of disaccharides are sucrose, maltose and lactose. Sucrose, maltose and lactose. In case of sucrose, aldehyde or ketonic groups are bonded. Non-reducing sugar. It is a non-reducing sugar. And in case of maltose and lactose, both the groups are free. Both the groups are free. Okay, they are the examples of reducing sugar. They are the examples of reducing sugar. Clear? So this is about the disaccharide information. So we can study about each and everything in the next slide. So let me start with the structure of glucose. Let me start with the structure of glucose. Okay. So this is the structure of glucose. You can see that it is a disaccharide. Two rings are there, right? One is a ring of alpha D glucose and the other one is the structure of ring of beta D fructose. And there is one linkage between carbon number 1 of glucose and carbon number 2 of fructose, which is called as glycosidic linkage, which is called as glycosidic linkage. So it is an oxide linkage formed between two monosaccharide by the loss of water molecule. Okay, just give me a minute. Okay. So the carbon number 1 of alpha D glucose and the carbon number 2 of alpha beta D fructose will form this linkage. Okay. And this molecule has only one glycosidic linkage and also it is a non-reducing sugar. It contains only one glycosidic linkage and it is a sucrose is the only non-reducing sugar in case of disaccharides. Okay. So this is all about sucrose. So there is carbon number 1 and carbon number 2. C1C2, C1C2 glycosidic linkage. All right. Now let us go for the structure of maltose. So in case of maltose, we have the glycosidic linkage between carbon number 1 and carbon number 4 of two molecules. The two molecules are alpha D glucose only. Both of them are alpha D glucose. So this is the glycosidic linkage. The C1 of alpha D glucose forms the glycosidic linkage with the C4 of alpha D glucose. Okay, and also it contains one glycosidic linkage. It is a reducing sugar. Maltose is a reducing sugar which has C1, C4 glycosidic linkage. Clear? There in the previous case, we had C1, C2 linkage and here we have C1, C4 linkage. And the next is structure of lactose. So in case of lactose, the linkages are beta. It is not alpha, you can see. They are present in a zigzag fashion, right? So the beta D galactose and beta D glucose forms this linkage. Okay. Beta D galactose and beta D glucose. And it is also the glycosidic linkage only. So carbon number 1 of the first molecule forms the linkage with the carbon number 4 of the other molecule. It also contains only one glycosidic linkage. Lactose is a reducing sugar. So C1, C4 glycosidic linkage is formed. Clear? So sucrose is a non-reducing one, but the other two, maltose and lactose, are the reducing sugar. So this is all about the disaccharides. And in the next class, we can discuss about the polysaccharides. Okay. Students, do you have any doubt from today's session? Do you have any doubts from today's session? So today we have started the biomolecules and some of the carbohydrates parts were discussed. Okay. And initially we have started with the classification, the definition, and we have come into the monosaccharide parts and we have discussed some reactions and preparations of glucose there. Then we have covered some parts of fructose. Then we have covered disaccharides also. The next is polysaccharides that we will discuss in the next class. Clear? Do you guys have any doubt? Okay then, thank you so much for listening. See you all in the next class. Take care. Bye-bye.